Hi everyone, today we'll be talking about function notation. We're going to start off with two vocabulary words, independent variable and dependent variable. These both should be familiar, whether you've heard them in science class or you remember them from pre-algebra. Independent variable is a variable that provides input values of a function. It's your x values. A dependent variable is a variable that provides output values of a function. It's your y values. You can also think of it as your y values depend on your x values. Alright, so now let's use function notation. Wait, what is function notation? Well, function notation is just this, an f with an x inside parentheses. We read this as f of x. But what does it actually mean? Well, it just represents the letter y. So when we have a function like we have down here, y equals 5x, we could also write it as f of x equals 5x. So that f of x and that y mean the exact same thing. Alright, so now when we take a look at this first example, they want us to make a table for each function, then identify the range of each function. So they give us this set of domain values, and they want us to use that to then find a set of range values. So we're going to take our domain and we're going to input it into the table. And our function tells us that all of our y values are equal to 5 times each x value. So if I take 5 and I multiply it by the x value, it's going to give me the y value. So we can do that all the way through. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So my range is those y values, 0, 5, 10, and 15. And remember, same rules apply when we write out our domain and range. We have to use curly brackets. We have to put them in order least to greatest. And we cannot have any repeating numbers. Alright, so I want you to come down here and do the same thing. Pay attention because that coefficient of x here is a -1. So you're going to multiply each x value by -1 and then add 2 to get your set of range. Go ahead and pause the video now. Okay, let's go to the next page. This time we're going to use the table to find the range of f of x equals x plus 1. So remember, f of x is the same thing as just saying y equals x plus 1. All of our y values are equal to taking the x value and adding 1. So take my x value, add 1, that'll give me my range. So -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2, and 2 plus 1 is 3. Alright, now we can plot each of those points. I have one here, here, and here. Alright, what would happen if we tried to connect those points? Alright, well, if I try to connect them, I end up with this line. But I can extend that line because even though we're only seeing a small portion of that function, it actually keeps going. So I can actually extend my line all the way through. And there's my full function. Alright. Now, is our graph a relation? Well, yes it is, because anything that's a set of ordered pairs is a relation. Now, is our graph a function? Yes, it is. It passes that vertical line test. No matter where I draw a vertical line, I'm only ever going to hit that graph once. Alright, now let's take a look at this one here. Here they give us this function, and then they give us the range. They give us the y values, or the f of x values. We have to figure out what x equals for each one. So this one's going to require a little more work, and some equation solving. So what we need to do is take this value, substitute it in for f of x, and then solve for x. So I'm going to take that original function, and I'm going to replace my y value, or my f of x value, with -9. And now I can solve. So I'm going to add 8 to both sides. Now to get rid of that divided by 2, I can multiply both sides by 2. And now we're left with -2 equals x. Now I could do it again. I'm going to follow those exact same steps every single time. It's just this time, the number that I replace f of x with becomes the second number here. So just like before, I'm going to add 8 to both sides, and then multiply both sides by 2. And now I'm left with x equals -1. Can do the same thing over here. This time I replaced f of x with -8. Multiply both sides by 2. And x equals 0. And one more time. This time we're going to replace that f of x with -7. Finish solving. And you'll notice I'm following the exact same steps that I did earlier. Every time I added 8 and then multiply both sides by 2. This time we're left with x equals 2. Okay, so now we found our domain. All right, I want you to go ahead and try these on your own. See it, and if you think about it, see if you can find a quicker way to do it. Okay? So I just showed you the long way. There is actually a quicker way. See if you can figure that out and then attempt these. If not, then go ahead and use the way that I showed you up above. Go ahead and pause the video now. All right, let's go to the next page. All right, so let's talk intercepts. So an x-intercept is the point where a graph crosses the x-axis. Remember, our x-intercept, or our x-axis is this horizontal number line. A y-intercept is where the graph crosses the y-axis, or the vertical number line. So how are x and y intercepts written? Well, like this, where we usually have a number, comma 0 for our x-intercept, okay? Because it's the x value that we have a number for. And then our y-intercept is always written 0, comma a number. Okay? So this is actually our x value, so I'm actually going to take that out, and I'm going to replace that with x. So that's our x value and our y value. All right, I like that better. All right, so what are some synonyms for an x-intercept? A little typo there. All right, an x-intercept, we can call them solutions, we can call them roots, or we can call them zeros. We'll get more into this later this year as well, where we'll circle back around to these vocab words and they're going to become even more important. So right now we're just kind of introducing those words. But whenever you hear x-intercept, it also means solutions, roots, and zeros. All right, so let's take a look at this graph here. Given the following graphs, what are the intercepts? What are the zeros? Is the graph a function? All right, so let's start with our x-intercepts. How many times does this line cross the x-axis? It only crosses it once, right here. So looks like about -7, comma 0. So that's our x-intercept. Our x-intercepts are always written as an ordered pair. All right, remember, x-intercepts can also be called solutions, roots, or zeros. So when they ask for the zeros, all we really want is just the x value. So in this case, -7 is my 0. Now we look at our y-intercept. It's this guy up here, so it would be 0, 6. All right, I want you to go ahead and try this one on your own. Identify the x-intercepts, the zeros, and the y-intercepts. Go ahead and pause the video now. All right, let's go on to our last page. So here we have another type of function. Oh, actually, before we do that, let's come back over here. And we wanted to know, was this a function? So when we looked at this particular graph here, they wanted to know, was it a function? Okay? So is it a function? In this case, yes it is. So when you do the try on your own down here, please also indicate if this is or is not a function. All right, so now let's come over here and same kind of thing. So first our x-intercepts. So take a look at this and how many times does this cross the x-axis? It actually crosses twice. We see it cross once right here. And we see it cross again over here. Okay, so we have two x-intercepts, so we're going to write both of them down. It looks like I have -1, 0, and then 3, 0. All right, now my zeros, remember they're just the x values from my x-intercepts. So I've got a -1 and I have a 0. All I do is list out my x values from the x-intercepts. No parentheses, no brackets, I'm just listing out those x values, and that's it. Right? My y-intercept, well, where do we cross the y-axis? Well, it looks like we're crossing the y-axis right about here. So the ordered pair for that one would be 0, -3. I want you to try this one on your own. Oh, before we do, come back up. Is this a function? So quick little review. Is it a function? If I draw a line, vertical lines anywhere through, I'm only ever going to hit that parabola once. So we say yes. All right. Last one. Try on your own. And then this is the end of our notes, so you can go ahead and stop the video now, and then make sure you've completed all your try on your own. I will see you in class next time.